Everyone is calling Build 2026 the AI event. They're focused on the keynotes and the new models. But the real shift is much quieter. It isn't happening in the headlines. It's happening in the structure underneath. But here's what actually changed. We moved from chatbots that assist to agents that operate. That sounds like a small feature update. It isn't. It's a fundamental shift in how we build. It changes identity, governance, and orchestration. It's the infrastructure layer, the stuff you can't see in a demo. Most organizations are building agents that are fragile. They pick products without understanding the model. They deploy without any governance. They end up with multiple agents doing the exact same work because they don't know what already exists. They're about to hit a wall. We need to move past product names. We need to look past what's in preview and what's ready now. We have to look at the structural reality of how agents work, because that determines if your deployment scales or if it fails. Let's start with the model that makes sense of the noise. The 4 layers, how to think about agents. The problem is simple. There are too many agent products. You have Security Copilot and Dynamics agents. You have Azure agents and Copilot Studio. Then there's Foundry, GitHub Copilot, and Microsoft Scout. Most organizations don't have a mental model for which one to use. They pick based on a recommendation or a random headline. That isn't a strategy. The solution is also simple. Stop thinking about agents as products. Start thinking about them as a system with 4 layers. Each layer has different needs. Each layer requires different people to make decisions. When you confuse these layers, your deployment fails. Experience layer. This is where humans talk to agents. It includes Copilot and Microsoft Scout, which is the always-on work agent. It includes GitHub Copilot and the agents built into Word or Excel. You also have computer-using agents that click and navigate, just like a person does. This layer is about discovery. Most companies start here, but they also stop here. And that's why their setup is fragile. Agent layer. This is where specific intelligence lives. Security Copilot has agents for phishing and threat intelligence. Dynamics 365 has agents for sales and customer intent. Azure Copilot has agents for migration and troubleshooting. These aren't generic assistants. They are built for one specific job with one specific context. An agent that doesn't understand your domain is just a chatbot that's going to hallucinate. But once you have a dozen of these running, you hit a problem. You have to figure out how to control what they can actually access. Runtime layer. This is where agents execute. It's where they keep track of their state and call other tools. Foundry Agent Service is the platform that manages this. You define the logic, and Microsoft handles the scaling and the networking. The runtime manages memory, including how to do things and what the user prefers. Multiple agents live in the same runtime and call each other as tools. A coordinator agent can delegate tasks to a specialist. This is infrastructure. It isn't a feature you just bolt on at the end. Governance layer. This is the part most organizations are missing. It covers identity, policy, and audits. Agent 365 is the governance plane for all of it. Every agent gets its own identity in Entra. It isn't a shared account or a human account. It's a unique principle. That means you can use least privilege access. You can revoke an agent's power. You can audit an agent just like any other system. Because of Purview, every action an agent takes goes into an audit log. You can apply the same policies to agents that you apply to your users. Before Agent 365, these agents were invisible. Now they are governed like infrastructure. Each layer has different owners. They have different controls. Most projects fail because the team is building in one layer while they think they're in another. Or they just skip governance entirely. When you understand these 4 layers, you can navigate the whole ecosystem. It's the difference between picking products at random and making a real architectural decision. So let's look at what actually changed at Build 2026 to make this model real. Build 2026, the moment agents became infrastructure. Everyone heard the same headlines coming out of Build 2026. Computer-using agents went GA, Copilot Studio got a redesign, voice agents arrived, and teams got a fresh set of agent features. It is a solid product roadmap. It is exactly what you would expect to see at a major conference. But there is a quieter headline underneath that one. Nobody opened the show with it. It did not get the keynote spotlight. Agent 365 moved from preview to general availability on May 1st, 2026, and Foundry Agent Service hit GA back in March. For the first time, you have a governance plane and a runtime plane actually talking to each other. That is not just a new feature. That is the moment the infrastructure became real. Let's look at what Agent 365 actually does. It treats agents as first-class identities, not features, not capabilities bolted onto your existing systems. Identities. Every agent gets its own identity in Entra, which means it is not a shared service account or a human user account mapped to a bot. It is its own principal. It has its own identity in your directory, just like any other actor in your system. That changes everything about what is actually possible. Because once an agent has its own identity, it can have its own permissions and its own audit trail. You can apply conditional access policies to it, put it through regular access reviews, or revoke its credentials in an instant. You can see exactly what it accessed, when it happened, and why it was there. The shift here is subtle but fundamental. You are not just using an agent anymore, you are hiring one. It comes with all the governance machinery that you would expect when hiring any other system. You get purview audit logs that track every move it makes and Entra policies that constrain exactly what it can reach. It is not a feature you just turn on. It is a system you are now accountable for. Foundry Agent Service hit GA in March, and that is the runtime piece of the puzzle. This is the managed platform where agents actually execute and maintain their state. It is where they coordinate with other agents and call tools at scale. You get procedural memory that lets agents learn how to do things across different sessions. You get user memory that persists, preferences, and session memory for context. These agents run in sandboxed sessions that Microsoft manages for you. Scaling is handled automatically, so you define the logic while Microsoft handles the heavy lifting. Before Build 2026, Foundry was just an experimental platform. It was interesting, but it was not enterprise-grade because the governance layer did not exist yet. You could build agents, but you had no way to govern them at the organizational level. Now, both pieces are GA and production-ready. They are designed to work together from the ground up. Agent 365 discovers and governs, while Foundry hosts and executes. One gives you identity and policy, and the other gives you runtime and orchestration. Neither one works without the other in a real deployment. That is the convergence that matters. For the first time, organizations have the actual infrastructure required to run agents at scale with governance baked in. It is not bolted on after the fact. It is identity first, policy-driven, and fully auditable. This is why the change is structural. Before Build 2026, agents were just features. They were advanced features, but you still just built one and hoped it did not break anything. You had no visibility into what it was accessing. If it went rogue, you had no clean way to shut it down. After Build 2026, agents are infrastructure. They have identities, policies, and audit trails. They run on managed platforms that scale and coordinate with other agents. They are governed, like any other system in your environment. That is not just a product announcement. That is the moment when building agents stopped being experimental and started being operational. The 4 layers we talked about are no longer just concepts. They are an architectural reality. This changes how you should be thinking about your agent strategy right now. The question is no longer which agent product you should try. The real question is how you architect agents across your entire organization. The experience layer, where work begins. So we have established the model. Now let's look at what each layer actually does. We will start with the experience layer because this is where most people encounter agents. This is the surface. This is what you interact with every day. The experience layer is straightforward in concept. It is where humans interact with agents directly without needing to think about infrastructure or governance. It is just you and an agent getting work done. But even this surface-level thinking has changed. Microsoft Scout is the clearest example of how this works now. Scout is positioned as an always-on personal work agent. It is not a chatbot you ask questions, and it is not something you have to manually invoke. It is an agent that watches what you are doing across Teams, Outlook, OneDrive, and SharePoint. It acts proactively. You are in a meeting, and Scout monitors the conversation. You are preparing a document, and Scout watches the context. Without being asked, it surfaces relevant information and flags decisions you need to make. It does not wait for you to formulate a question because it understands your context and anticipates what you need. Compare that to traditional Copilot, which is reactive. You open Word and type a prompt to write an introduction to a report. Copilot responds, and it is helpful, but it is still a Q&A model. You ask and it answers. Scout flips that entirely. It observes and then it acts. That is a fundamentally different way to interact with software. GitHub Copilot CLI brings that same agent concept to developers in a completely different environment. You are in a terminal and you need help with a Git workflow or a command you cannot remember. Instead of switching to a browser to look at documentation, the agent operates right there in your terminal. It is the same principle as Scout, just on a different surface. Then you have agents embedded in the applications themselves. Word has an agent that understands the tone and audience of the document you are writing. Excel has an agent that knows your data structure and helps you analyze it. PowerPoint has an agent that understands the story you are telling with your slides. These are not generic assistants. They understand the specific context of the work happening in that specific application. Copilot Studio sits somewhere different on this layer. It is the tool that lets teams build custom agents without writing any code. You use a low-code interface to define the behavior you want and connect your knowledge sources. You test it and then you launch it. Most organizations start here because the bar to entry is genuinely low. Computer-using agents take a different approach entirely. Instead of understanding natural language and calling APIs, these agents see your screen. They watch your UI, click like you do, and navigate exactly like a human would. This matters for legacy systems that do not have clean integrations. A computer-using agent can work with any system a human can work with. Here is the pattern you see across the experience layer. It is all about accessibility and meeting people where they already work. Whether it is in Teams, a terminal, or a calendar, the infrastructure is not the focus. The experience is. You want to know how quickly you can get value and how well the agent fits into your existing workflow. Most organizations start right here. They try Scout, build something in Copilot Studio, and enable Copilot in their apps. They see the value and they think they are done. And that is where the fragility comes in. Because the experience layer is only one layer. It is the visible part, but underneath, there is a whole architecture that determines whether this actually scales. It determines whether your data stays secure and whether you can actually manage these agents according to your company policies. The agent layer, domain-specific intelligence. Under the surface experience, something else is operating, the agents themselves, and this is where the model matters, because an agent built for security is fundamentally different from an agent built for sales. They have different training, different constraints, different contexts, they serve a different purpose. That is the agent layer. The agent layer is where domain-specific intelligence actually lives. These are not generic assistants, they are not chatbots that sort of help with anything. These are agents built for a specific job in a specific context with specific constraints they understand deeply. Take security copilot agents as an example. These are not general-purpose assistants that happen to work on security. They were built from the ground up to understand security signals, threat patterns, and remediation workflows. There is a phishing triage agent that analyzes suspicious messages. It separates likely phishing from legitimate mail and helps analysts prioritize what to investigate. That is not a generic language model answering questions. It is a specialist agent that understands email signals the way security teams understand them. Alert triage agents work the same way. Security teams get flooded with alerts every day. Most are noise, but some are signals. The alert triage agent learns to distinguish between them because it understands context. It knows which alerts cluster together to suggest a larger incident and surfaces what actually requires human attention. It was built for that specific problem. Conditional access agents, vulnerability remediation agents, and threat intelligence agents are all specialized. Each one has been trained on domain-specific data and workflows. Each one has constraints built in because security people understand what bad output looks like and what could cause harm. Then look at Dynamics 365 agents. This is a completely different domain. The sales qualification agent is not a chatbot. It was built to understand lead scoring criteria, customer fit, and pipeline progression. It assesses inbound leads against what your sales team actually cares about and surfaces high probability opportunities instead of everything that comes in. The account reconciliation agent solves a different problem. Finance teams spend enormous amounts of time matching records like invoices to payments or purchase orders to receipts. The agent understands matching logic and knows what constitutes a match. It flags exceptions and reduces the hours humans spend on purely mechanical work. The customer intent agent works across multiple channels. Sales and service teams have interactions through email, calls, web forms, and social media. The agent analyzes those signals to understand what the customer actually wants underneath what they explicitly asked for. This helps teams respond with better timing and better solutions. Supplier communications and field service each have their own agents built for specific domains with specific workflows. Azure brings its own set to the table. There are migration agents for assessing and planning complex Azure migrations and deployment agents that guide implementation once the architecture is decided. Optimization agents run on existing environments to improve cost, performance, and utilization. Observability agents connect disparate telemetry signals to surface what is actually happening in your infrastructure. Resiliency agents strengthen fault tolerance before failure happens, and troubleshooting agents diagnose problems faster than humans can. And then there is the open category. Copilot Studio lets teams build custom agents for business-specific workflows that do not fit any pre-built pattern. These are processes unique to your industry or workflows specific to your organization. Those agents are built by business teams who understand that context deeply. The key distinction is that these are not generic assistants with domain knowledge bolted on. They were built from the ground up for a specific job. They have constraints, they have specialized training, they understand the specific signals that matter in that domain. This means an agent that does not understand your domain is just a chatbot with hallucination risk. A security agent applied to sales is useless. A sales agent applied to operations is worse than useless because it will be confidently wrong. But this creates a governance problem. Once you have dozens of specialized agents running across your organization, you have to control what they access. Some are pre-built, some are custom, and some are from vendors. You need to keep them aligned with policy, and you need to know they even exist. That is where the runtime and governance layers become critical. The runtime layer, where agents actually execute. The infrastructure where agents actually run is a different problem entirely. Once you have agents with specialized capabilities, they need somewhere to live. They need a place to maintain state, call tools, and connect to data. They need to coordinate with other agents doing related work. That is the runtime layer. Foundry Agent Service is the managed platform for this. Think of it like this. You write the agent logic and define what it should do. You specify what tools it needs access to, and then you hand it to Foundry. Foundry handles everything underneath, including scaling, isolation, networking, and identity. It manages session management and state persistence, so you can focus on the logic while Microsoft manages the infrastructure. That distinction matters more than it sounds. Building agents yourself means managing containers, scaling groups and databases for state. You have to manage memory and networking. Building agents on Foundry means you are not managing any of that because the platform does it for you. You define the agent and deploy it, and then it runs. This is what managed actually means in practice. Agents run in hosted sessions where each session gets its own sandbox. The session has file system access and persistent state that survives across interactions. When a user talks to an agent, that conversation maintains context. When the agent needs to do work, it has a place to store intermediate results. When another agent needs to call this agent, the call goes through a standard protocol. Microsoft handles the isolation and the scaling. If traffic spikes, the platform scales automatically, and if one agent fails, it does not cascade. Memory is built into the runtime instead of being bolted on. This is where the model shows its maturity. Procedural memory means agents remember how to do things. Once they have executed a workflow, they remember the steps, which makes them faster and more accurate the second time. User memory persists across sessions, so an agent learns your preferences, your constraints, and your typical patterns. It carries that forward. Session memory holds context for the current conversation, but only the current conversation. Once the session ends, session memory goes away, but procedural and user memory stick around. Multi-agent orchestration happens in the runtime. One agent can call another agent as a tool. You have a coordinator agent that breaks down a complex task and calls a data retrieval agent. That agent goes to fetch information and then calls an analysis agent. That agent processes what was retrieved and calls a communication agent to draft a response. The coordinator stitches it all together while the runtime handles the choreography. Each agent knows what tool it is calling and what response to expect. If one agent fails, the coordinator can retry or escalate. The agent-to-agent protocol standardizes this process. Agents do not just work within Foundry. They can call agents built on other frameworks as long as they speak the A2A protocol. Agents built on semantic kernel can call agents built on AutoGen. Custom agents can call pre-built agents. They do not all have to run on the same platform as long as they understand the protocol. Toolboxes are the discovery mechanism. Instead of hard-coding every tool an agent might need, toolboxes let agents discover tools at runtime. A toolbox is a collection of tools, integrations, and data sources. An agent looks at the task it is facing and checks what is available in the toolbox. It selects what is relevant and uses it. If new tools get added to the toolbox, every agent automatically has access without any redeployment or reconfiguration. Foundry IQ is the knowledge layer underneath. It unifies retrieval across documents, data warehouses, web content, and enterprise sources. An agent that needs to answer a question does not have to know where the answer lives. It asks Foundry IQ and the platform finds it. It returns relevant context and the agent uses that context to construct a response. There are no custom RAG pipelines to build and no vector databases to manage. Foundry IQ handles the orchestration of multiple retrieval sources. The reason runtime matters is simple. Without a managed runtime, you are building agents that run in your own infrastructure. You are responsible for scaling, state management, and keeping them secure. You have to make sure they do not break other systems. With Foundry, you are building agents that scale automatically and maintain state without your involvement. They coordinate with other agents without custom orchestration and access tools, without hard-coded integrations. The runtime is what lets you move from experimental agents to operational agents at scale. The governance layer sits on top and controls all of this, but the runtime layer is what makes it actually work. The governance layer, the missing piece. The runtime layer gives you the basics: hosting, memory, scaling. But infrastructure without control is just chaos. That is where the governance layer comes in. Before Agent 365, agents were essentially invisible. You would build an agent in Copilot Studio and it would just run somewhere. It might be in the Power Platform or a custom environment or even on a laptop running a local script. Nobody knew it was there. It did not know. Security did not know. The organization had no idea what was operating, what data it was touching, or who was even responsible for it. That invisibility was fine when agents were just experiments. It became dangerous the moment they started calling real APIs and making decisions at scale. The governance layer changes that. It makes agents visible. More importantly, it makes them manageable. Agent 365 acts as a central registry. It discovers every agent in your tenant, not just the ones you officially deployed. It finds the agents in Power Platform environments that have not been touched in 6 months, and it surfaces the Copilot Studio bots someone built in a private workspace. It discovers shadow agents that nobody told it about. For the first time, you can actually see what is running. But discovery is only the start. Once you see an agent, you have to control it. And that is where Entra Agent ID changes the model. Every agent gets its own identity in your Entra directory. This is not a shared service account or a human account mapped to a bot. It is its own principle. When an agent acts, it acts as itself. It has its own permissions, its own audit trail, and its own lifecycle. That sounds like a minor detail. It is not. It is foundational. Because an agent with its own identity can follow the rule of least privilege. If an agent only needs to read from one specific SharePoint library, it gets read-only access to that library and nothing else. It does not get broad access to all of SharePoint. It does not use a service account that can read every file in the company. It gets exactly what it needs to do the job. That is the opposite of how agents usually work today. Right now, they either have no identity at all or they run under a service account with permissions that were set once and never checked again. With Entra Agent ID, every agent is secure by design. Because every agent has its own identity, you can scope that identity with total precision. If an agent goes rogue or gets compromised, you simply revoke its identity. It stops immediately. It does not wait for a manual shutdown or a service restart. It dies the moment the identity is gone. Every action an agent takes is logged under its own name. Because of Purview integration, that audit trail flows into the same logs that track everything else in your environment. You can see what every agent accessed and exactly what it did. For compliance or for figuring out what went wrong, the trail is finally complete. The same conditional access policies you apply to humans now apply to agents. If your policy says sensitive data must only come from a managed device, that rule applies to your agents too. If you restrict access based on risk or location, agents have to follow those rules. You are no longer managing agent security in a separate silo. It is all one system. The agent control specification lets you define what agents are allowed to do. This is different from access control. It is about actions. Maybe an agent can read documents but cannot modify them. Maybe it can send a message but cannot delete one. You define the boundaries. And the runtime enforces them. This is the structural shift. Before Agent 365, agents were invisible and uncontrolled. Now, they are governed like any other system. They have identity, they have audits, they have a life cycle. Governance is not an add-on. It is infrastructure. The decision framework, Azure and GitHub agents. We have covered the layers. You understand the model. But the model does not tell you which agent to actually use. That requires a decision framework. And it starts with a simple question. Is the work you are doing focused on infrastructure or on developers? If the work is about deployment, operations, or cloud optimization, you are looking at Azure agents. These are specialized for the cloud. They understand the specific problems that operations teams deal with every day. Take the migration agent. You use this when you are planning a move to Azure with complex dependencies. Your environment likely has systems that talk to each other in ways you do not fully see. The migration agent understands those relationships. It maps what is connected to what and finds the dependencies you might miss during a manual check. It surfaces the risks of moving system A before system B. This speeds up the assessment phase where most companies waste months just documenting what they own. The deployment agent is for a different stage. Use this when the architecture decisions are already made. You know where the workloads are going and what services you need. Now you need a guide for implementation. How do you deploy this at scale? How do you make it repeatable so the fifth deployment is as clean as the first? It helps you build a process so someone else can deploy the same setup without needing the knowledge inside your head. The optimization agent runs on environments that are already live. Use it when you are past the setup phase and into a steady state. Your infrastructure is running, but you might be spending too much on compute or leaving performance on the table. This agent analyzes what you are actually using versus what you are paying for. It finds right-sizing opportunities and unused resources. It is not about changing the architecture. It is about making what you have run more efficiently. The observability agent is for when you have plenty of data, but the signal is buried in noise. Your systems are producing logs, metrics, and traces. Connecting those signals into a real understanding of what is happening is the hard part. The observability agent looks across all your data sources to correlate events. It helps you understand not just that something failed, but why it happened. The resiliency agent works before things break. Use this when you want to strengthen your fault tolerance. What happens if a database goes down? What happens if a network connection fails? The resiliency agent looks for weak points in your architecture. It suggests improvements so you can build in redundancy where it actually matters. The troubleshooting agent is for when things go wrong. Something broke and you need a diagnosis fast. The problem could be in the network, the app, or the database. This agent pulls signals from every source at once. It diagnoses faster than a human because it does not have to switch between different tools and documentation. It sees everything at the same time. GitHub Copilot CLI is the version for developers. Use this when teams need help without leaving their workflow. They are in the terminal and they need a command or help with an error message. Instead of switching to a browser, the agent operates right there in the environment where the work is happening. The modernization agent helps teams update old code without starting from scratch. You have legacy systems that need to move toward a new architecture. This agent understands those patterns. It suggests the best approach and can even help with the actual refactoring. The code review agent improves quality at scale. When humans review every pull request, the process is slow and inconsistent. You can add an agent to do the first pass. It checks for security flaws and performance issues. Humans still do the final review, but they are looking at code that has already been cleaned up. The pattern here is clarity. You are not asking which agent is the most advanced. You're asking what specific problem you need to solve, and which agent is built for that task. The decision framework, Dynamics 365 and M365 agents. Azure agents operate on your infrastructure, but Dynamics and Microsoft 365 agents operate on your business. That distinction matters because the decision point is different. You aren't asking what technical problem you need to solve. You're asking where intelligence is already sitting inside the way your people actually work. Take the sales qualification agent. It exists because your sales team is drowning in leads. Your inbound volume is high, but most of those leads are low probability. Your reps spend their entire day assessing people instead of selling to them. This agent looks at every lead against your specific criteria. It understands what a qualified opportunity looks like for your business. It separates the high probability wins from the noise. Because the agent handles the filtering, your reps can finally focus on the opportunities that are actually worth their time. The account reconciliation agent solves a different problem. Finance teams spend hours matching invoices to payments. Operations teams reconcile orders to shipments. It is mechanical work, it is time-consuming. And because humans get tired doing repetitive tasks, it is incredibly error-prone. The agent understands your matching logic. It knows what a valid match looks like and flags the exceptions for a human to review. This reduces hours of pure manual labor. Now your finance team audits the results instead of doing the reconciliation themselves. The customer intent agent listens across every interaction. A customer sends an email. They call support. They fill out a form or post on social media. Those interactions contain signals about what they actually want, even if they don't say it explicitly. The intent agent analyzes those signals to surface patterns. It helps your team understand what the customer is signaling so you can respond at the right time. You aren't just answering a question. You're understanding what is really needed. The supplier communications agent handles a very specific friction point. Supplier interactions are frequent and operational. They usually follow the same repeatable patterns. Someone asks to expedite an order. Someone else wants a delivery status or an inventory check on a specific SKU. The agent handles these routine inquiries and only escalates the genuinely complex issues to a person. It cuts out the operational overhead of that constant back and forth. The field service agent coordinates complexity. When a technician is dispatched to a job, the agent pulls all the context together. It looks at the service history on the equipment, known issues with that model, and the availability of parts. It even estimates the time to repair. The agent coordinates the next appointment before the current one is even finished. It ensures the follow-up actually happens. This reduces the coordination overhead that usually requires a dispatch team to manage by hand. Agents in Word, Excel, and PowerPoint embed intelligence directly into the tools where knowledge work happens. If a writer is working in Word, the agent understands the tone and the audience. It helps them without pulling them out of their flow. If an analyst is building a spreadsheet, the agent understands the data structure. It helps build formulas, finds errors, and suggests the right visualizations. A presenter building slides can use an agent to maintain narrative flow and story coherence. None of this requires leaving the app. None of it breaks your focus. Copilot Studio is the catch-all for custom agents. When your business process doesn't fit a pre-built pattern, you build it here. If your workflow is specific to your industry or how your company operates, you can create what you need without writing code or hiring developers. It allows business teams to build for their own specific needs. The pattern here is fundamentally different from the Azure side. Azure agents solve infrastructure problems. Dynamics and M365 agents embed intelligence into the systems your teams use every single day. You aren't bolting on new tools. You're making your existing tools smarter. You aren't asking teams to learn a new interface. You're putting the help exactly where the work is already happening. That is why this scales differently. An IT ops team might have to learn a new platform like Foundry, but a sales rep doesn't have to learn anything new at all. Their existing CRM just suddenly has intelligence. A finance person doesn't need software training because their spreadsheet now helps them work faster. Your support team doesn't need a new system. Their existing tools just got better. The advantage is obvious, but the challenge is deeper. Embedding intelligence into business systems requires a deep understanding of how those systems work. You have to understand the workflows, the data models, and the rules your people live by. A generic agent cannot do that. The agent has to be built for your specific business. This is why governance and orchestration matter. You aren't just running one or two tools anymore. You're managing dozens of specialized agents across your entire company. Without a framework, that becomes chaos. The shadow agent problem. Why governance isn't optional. Most organizations haven't confronted this reality yet. You likely have agents running in your tenant right now that IT doesn't even know about. This isn't because IT is bad at their job. It's because building agents has become trivially easy while governance remains hard. Teams would rather build first and ask for permission never. These agents are hiding everywhere. Someone spins up a Copilot Studio environment to build a tool for their department. They don't tell IT because they don't see it as infrastructure. To them, it's just a feature in a platform they already use. A Power Platform team creates a bot for their own automation. A Teams channel has a bot handling admin tasks. Someone else is running a custom Python script that calls an API. Even your vendors are bringing their own agents bundled into their software. By the time IT realizes these exist, dozens of them are already in production. They are accessing data and making decisions, but nobody is officially responsible for them. The risks start to compound quickly. You might have an agent reading your entire SharePoint tenant because someone granted it broad permissions without thinking about security. Another agent might be sending emails from a shared mailbox with no audit trail to show who actually sent them. You could have agents calling APIs with credentials stored in plain text. Often a dozen different agents are doing the same work, but nobody knows it because they aren't registered anywhere. They access restricted data, duplicate effort, and create massive data quality problems. This happens because the friction is asymmetrical. Building an agent is frictionless. It takes hours instead of weeks. Governance is the exact opposite. It requires planning, coordination, and policy definitions. Most organizations haven't built that process yet, so teams take the path of least resistance. They build, they test, and they deploy. They just skip the governance part entirely. This is where Agent 365 changes the structure of the problem. It doesn't require you to have a perfect governance process in place before you start. Instead, it provides visibility. It discovers the agents that are already running, every agent talking to Entra, every agent accessing M365 data, and every bot in the Power Platform is surfaced. It doesn't depend on teams registering themselves. It finds what already exists. But discovery is only half the battle. Once you find an agent, you have to be able to control it. The Entra Agent ID requirement changes the baseline for security. Every agent gets its own identity in your directory. When IT finds an agent with too much access, they don't have to shut it down or beg the creators to fix it. It can scope that identity themselves. They can apply access controls directly to the agent. If it only needs to read one specific SharePoint library, IT grants access to that library and nothing else. The agent can't accidentally or maliciously touch anything else. The scope is locked. If an agent starts misbehaving, you can revoke its access instantly. You don't need to have a meeting with the team that built it. You just revoke the identity. The agent stops working right then and there. Every single action that agent takes is logged under its own identity. When something goes wrong, your logs won't just show that a system account accessed the data. You will see exactly which agent did it and when it happened. The audit trail leads directly to the source. This is why governance isn't an optional add-on. It isn't something you bolt on after you have 50 agents running. It is the foundation that makes visibility and control possible in the first place. You cannot govern what you cannot see. Agent 365 makes those agents visible. You cannot have control without identity. Entra Agent ID makes those agents controllable. Together, these tools solve the shadow agent problem. The goal isn't to stop teams from building. The goal is to make sure those agents are manageable, auditable, and secure by design. If you skip this piece, you are building a fragile system. Foundry Agent Service, the production runtime. Governance is the control plane. But control only matters if there is something to manage. The runtime is what gives governance a purpose. It is the infrastructure where your agents actually live and operate. Foundry Agent Service is a managed platform. In practice, this means the division of labor is very clear. You write the logic, you define the goals, you pick the tools, then you deploy it into Foundry. Microsoft handles the rest. They manage the scaling, the isolation, the networking, and the persistent state. You focus on how the agent behaves while the platform handles the operational heavy lifting. Agents run in hosted sessions. Every session gets its own sandbox. When a user starts a conversation, that interaction is placed in an isolated container. The agent can read and write files within that specific session. It maintains state across multiple turns. If the session ends, that local state disappears. But you can design agents to remember things across sessions if the use case requires it. This isolation ensures that if one agent misbehaves, it won't crash your other executions. The Responses API is the single entry point for everything. When a system needs to call an agent, it hits this one endpoint. The API is agnostic to how you built the agent. It works with semantic kernel, it works with autogen, it works with the agent framework. Even custom code is fine as long as it follows the protocol. This is a big deal because it prevents vendor lock-in. Different teams can use different frameworks, but they all converge at the same runtime. Memory in Foundry is a core feature. It isn't bolted on. There are 3 distinct types. Procedural memory is how the agent learns workflows. It does a task once, remembers the steps, and becomes faster the second time. User memory stays active across sessions. The agent learns your preferences and constraints over time. Session memory is strictly contextual. It lives for the current conversation and vanishes the moment you close the window. This distinction changes how agents actually feel to the user. A sales agent with user memory knows your industry and your typical deal size. It uses that history to calibrate every suggestion it makes. But session memory keeps the current thread clean. When you start a new topic, you aren't fighting irrelevant history from 3 days ago. It prevents the context from getting polluted. Multi-agent orchestration happens naturally here. One agent can call another agent just like it would call a tool. You might have a coordinator agent talking to the user. When a complex request comes in, the coordinator breaks it down. It calls a retrieval agent for data. It calls an analysis agent to process that data. It calls a communication agent to draft the final text. The runtime manages this entire flow. Each agent knows what to call and what to expect back. If a step fails, the coordinator can retry or escalate the issue. Toolboxes are how agents find new skills at runtime. You don't have to hard-code every tool into the agent itself. Instead, you create a managed library. When an agent hits a problem, it checks the toolbox and picks the right tool for the job. When you add a new tool to the library, every agent gets access to it immediately. There is no redeployment and no configuration change. It is just instant availability. MCP support allows agents to talk to Model Context Protocol servers. These are external data sources that speak a standard language. You don't need to build custom connectors for every legacy system in your stack. The agent just needs to understand MCP. If a tool exposes that protocol, the agent can use it. Private networking is the final piece of the puzzle. For regulated industries, public endpoints are a non-starter. Foundry supports end-to-end private networking. Your agents run entirely inside your VNet. There are no public endpoints and no outside exposure. If you work in banking or healthcare, this is the feature that makes agent infrastructure possible. The outcome is simple. You aren't managing clusters. You aren't writing scaling logic. You aren't designing database schemas for conversation state. You define the behavior and let the platform handle the execution. Multi-agent orchestration, the real complexity. The runtime gives you a place to run your code, but running one agent is easy. Running dozens of agents that have to cooperate is where most projects fail. That coordination is the real challenge. It isn't that the agents are broken, they work fine. The problem is that orchestration is structurally difficult. Most organizations haven't built a model to handle it. The connected agents pattern is the simplest place to start. This is where one agent calls another as a tool. Think of a coordinator agent facing the user. It receives a request and breaks it into smaller tasks. It tells a retrieval agent to get information on a specific topic. It tells an analysis agent to find patterns in that data. Finally, it tells a communication agent to write the response. The coordinator then takes those pieces and stitches them together for the user. This model works, but it is sequential. One agent has to finish before the next one can start. That is fine for basic tasks, but for complex work, you are wasting time waiting on steps that could be happening at once. This is why we use multi-agent workflows. This is a stateful layer that sits above the runtime. It coordinates agents over long, multi-step processes. It isn't just a chain of calls. It involves branching logic and parallel execution. It handles errors and keeps state alive over long periods of time. Durable orchestration handles the most complex scenarios. Imagine an agent preparing a legal proposal. It submits the document for approval, and then it waits. This might take days or even weeks. When a human finally approves it, the workflow resumes with the full context intact. The agent doesn't have to reread the file. The state remembers everything. The execution just continues as if the pause never happened. Group chat is a completely different model. Instead of a top-down coordinator, multiple agents see the same message thread. They collaborate and they debate. The control shifts based on the needs of the conversation. If the group decides to try one approach and it fails, they can pivot to another. They are working the problem out together rather than following a fixed script. The choice between sequential and concurrent is about efficiency. You use sequential when step B depends on step A. You can't analyze data you haven't found yet. But you use concurrent when tasks are independent. You can pull data from 3 different databases at the same time and then merge the results. A good orchestration layer lets you mix both patterns in the same workflow. Then you have the handoff pattern. When a task moves from one agent to another, the transition has to be clean. It isn't enough to just pass the data. You have to transfer the context. The second agent needs to know what the first agent already tried. It needs to know what failed so it doesn't repeat the same mistakes. It picks up exactly where the last agent left off. The real complexity starts when you combine these ideas. You might have a workflow that is mostly sequential but has parallel steps in the middle. You might have agents collaborating in a chat while a human approval step pauses the whole thing. Context has to flow through all these different patterns without breaking. Most deployments fail here because the orchestration wasn't planned. Someone builds 3 great agents that work in isolation, but getting them to work together with proper error handling and audit trails is the actual work. A single agent is a useful tool, but multiple agents working in a coordinated system are transformative. They can solve problems that no single model can touch. Understanding these orchestration patterns is the difference between a toy and a production system. The identity shift, agents as principles, not features. The structural foundation of everything we've talked about comes down to one thing: identity. And how Microsoft fundamentally changed what an agent identity actually means. In most organizations building agents today, there's an old pattern. The agent runs under a shared service account. Maybe it's a generic automation account, or maybe it's a human user account that was mapped to the agent because someone needed a quick solution. The account has broad permissions because nobody wanted to be granular. When the agent acts, the audit log shows that generic account doing the work. You can't see which agent did what. You can't revoke just that agent. You can't apply policies to just that agent. It's invisible in the identity system. The new model is fundamentally different. Every agent gets its own Entra-agent ID. Not a service account, not a user account. Its own principal in your directory. It shows up in Entra like any other actor. It has its own credentials, its own audit trail, its own life cycle. That sounds like a technical detail. It's actually the foundation that makes governance possible. Start with credentials. In the old model, agents either had credentials hard-coded in configuration files or they inherited them from whatever account was running the process. Both approaches are vulnerable. Hard-coded credentials in files get checked into repositories where they get exposed and shared across multiple agents. If one agent is compromised, the credential is compromised for every single agent using it. With Entra Agent ID, credential management changes completely. The agent doesn't store credentials. It doesn't even know them. It requests a token from Azure. Azure validates the agent's identity. If the identity is legitimate and hasn't been revoked, the agent gets a token. That token is short-lived. It expires. It's tied to that specific agent. If the agent is compromised, the token is compromised, but only for that agent. Other agents are unaffected. More importantly, credentials stay in Azure Key Vault. They aren't in files or code. They're in a secured vault that's separate from the agent itself. The agent requests what it needs from Key Vault, which then validates the agent's identity and returns the secret. If you need to rotate a credential, you do it in Key Vault. Every agent that uses that secret automatically gets the new version. No redeployment, no configuration changes. The audit trail changes too. Every action an agent takes is logged with its identity, not a generic account, not a human user, the specific agent. When an audit log shows Agent X accessed this data at this time, you know exactly which agent did it. You can trace back to who built it, who deployed it, and who owns it. For regulated industries, this is transformative. You can prove compliance. You can show that access was controlled. You can demonstrate that unintended access was impossible because the agent's permissions were scoped to prevent it. Revocation is immediate. If an agent is compromised or misbehaving, you revoke its identity. Not let's shut down the process or let's escalate this to the team that built it. You revoke the identity in Entra. The agent stops operating immediately. Any request it makes is rejected because its identity is no longer valid. Everything downstream knows this agent is revoked. Conditional access policies work for agents the same way they work for humans. If you have a policy that says access to sensitive data requires a managed device, that policy applies to agents too. If you've set risk-based access controls, agents are subject to them. Access reviews include agents. If someone leaves the company, you don't have to hunt down every agent they built and disable it. If their identity is in a group that's being reviewed, agents they created show up, they get audited, they get disabled if necessary. The shift is structural. Agents stop being invisible infrastructure and become managed principles in your identity system. That's why it matters. You can't have governance without identity. With Entra Agent ID, governance becomes possible. Security agents, reducing analyst fatigue. Now that we understand the structural foundation, how agents get identity, how they're governed, and how they orchestrate, let's look at what this actually enables in practice. Security is where agents start delivering immediate value because the problem they solve is acute and measurable. The problem is straightforward. Alert volume in most organizations is overwhelming. Your SIEM generates thousands of alerts per day. Your email system flags suspicious messages. Your endpoint detection tools flag anomalous behavior. Your vulnerability scanners find issues. The volume is relentless. And security analysts, who are expensive and in short supply, spend their time wading through alerts that are 80% noise. They're looking for the 20% that actually matter. That's not security work, that's filtering. The phishing triage agent handles that filtering at the email layer. An organization gets hundreds of suspicious messages every week, and while some are legitimate, many are phishing attempts. The agent analyzes incoming messages flagged as potentially malicious by looking at sender reputation and message structure. It checks for common phishing indicators and separates likely phishing from legitimate mail. Not perfectly, nothing is perfect, but accurately enough that you're reducing the email analyst's review workload significantly. Instead of reviewing 50 messages to find 5 that actually need escalation, the analyst reviews 20 because the agent already filtered out the obvious cases. Alert triage agents work the same principle, but across the security infrastructure. Your tools are generating alerts. Some indicate real threats. Some are false positives. Some are legitimate findings, but low priority. The alert triage agent understands the relationships between alerts. It knows which ones cluster together and suggest a larger incident. It prioritizes based on risk context. It surfaces what actually needs immediate attention. If you had 1,000 alerts yesterday and 500 required investigation, but only 50 actually mattered, the agent helps security teams see the 50 instead of drowning in the 500. The conditional access agent operates differently. It's not triaging, it's helping security teams manage identity policy at scale. Most organizations have conditional access policies, rules that say things like require multi-factor authentication for sensitive data access or block access from unusual locations. But conditional access is complex. A change to one policy can have cascading effects across other policies and systems. The agent helps teams understand policy impact before they deploy changes. What happens if we modify this rule? Who gets affected? What breaks? Where's the risk? The agent helps teams operate their identity policies more safely. Vulnerability remediation agents address the backlog problem. Every organization has more vulnerabilities than resources to fix them. The agent doesn't just find vulnerabilities. That's what scanners do. It prioritizes by risk. It connects vulnerability data with threat intelligence. It understands which vulnerabilities are actually being exploited in the wild right now versus theoretical vulnerabilities. It helps plan remediation. What should we fix first? What can we defer? What do we need to monitor while we're waiting to patch? The agent reduces the time analysts spend prioritizing and planning. The threat intelligence agent connects internal signals with external context. Your organization has internal logs and observations, but threat intelligence, information about campaigns, threat actors, and emerging techniques, lives outside your network. The agent pulls those together. It helps analysts understand what they're seeing in that external context. This alert you're investigating, is it related to a known campaign? Are other organizations seeing similar activity? What's the likely motivation? How should we respond? M- is the testing layer. Security agents make decisions that matter. You need to validate those decisions before they go into production. M- is a security harness that tests agent workflows. It runs scenarios. It validates that agents are making the right calls. It ensures consistency. The pattern across all of these is identical. Analysts are expensive. Agents are cheap. If an agent can handle routine assessment and prioritization accurately enough that analysts focus their time on investigation and response instead of filtering, that changes the economics. Not by replacing analysts, by letting them do the actual security work. Business process agents embedding intelligence where work happens. The security example works because the boundaries are clear. Security agents live in a specific domain with specific tools and specific workflows. But most work doesn't happen in a vacuum. It happens inside the business systems your teams use every single day. That's where the real scale is. The shift from security agents to business process agents is fundamental. Security agents reduce the noise for an analyst. Business process agents actually become part of how the work gets done. They aren't separate tools you open when you need a hand. They live inside the systems where the work is already happening. Take sales qualification. Most sales teams are drowning in inbound leads. A campaign runs, the leads pour in, and then sales development reps spend hours trying to figure out which ones are actually worth passing to an account executive. Some leads are high probability, some are low probability but at the right company, others are just a waste of time. The sales qualification agent sits right in your CRM. The moment a lead arrives, the agent assesses it. It understands your specific sales criteria: deal size, industry, company profile, and use case fit. It scores leads against what actually matters to your business. The result is that sales reps see the high probability leads in their queue first. They spend their time on opportunities that deserve their attention rather than triaging every single person who filled out a form. Account reconciliation is similar, but it lives in finance. Finance teams upload transactions every day. They have to match them against existing records. Invoice to payment, PO to receipt, shipment to invoice. Historically, this meant someone sitting at a spreadsheet matching rows. It's mechanical work, it's slow, and it's prone to human error. The account reconciliation agent understands the matching logic. It knows what a valid match looks like. It connects the transaction data and flags the exceptions that don't match automatically. The finance team still reviews the work, they have to, but they're reviewing the outliers and validating the results instead of doing the manual labor. The customer intent agent operates on a broader scale. Your customer calls support. They send an email. They post on social media. Every one of those interactions contains a signal about what they actually want. But finding that signal is hard. The agent analyzes these interactions across every channel and surfaces the patterns. It tells your team what the customer is actually signaling underneath what they explicitly asked for. It's not just about answering the question. It's about understanding what's really needed so you can respond with better timing and better solutions. Supplier communications works the same way. If you're a large buyer, you get supplier questions constantly. They want to know if you can expedite an order, what the status is, or if you have inventory on a specific SKU. The supplier communications agent handles the routine stuff. It knows your inventory, it knows your lead times, it knows your escalation procedures. It answers the straightforward questions. When an inquiry requires human judgment, like a special request or a complex issue, it hands it off. Your supplier relations team can then focus on the actual relationships rather than answering the same 3 questions over and over. Field service takes that coordination and pushes it out to the edge. A technician gets sent to a job. The field service agent pulls together everything that person needs before they even arrive. Service history on the equipment, known issues with that specific model, current parts inventory, estimated time to repair. It can even schedule the next appointment while the current one is still happening. It flags if follow-up is needed and coordinates the logistics around the actual field work. The advantage here is obvious. These agents live in the systems your teams already use. A sales rep stays in the CRM, a finance person stays in Excel or the ERP, a support person stays in the ticket system. The agent helps them without pulling them out of their flow. But here's the problem. This is harder than it sounds. These agents can't be generic. They require a deep understanding of the business logic and data models that are specific to your organization. What counts as a qualified lead for you might be junk for another company. What a valid match looks like in your finance department depends on your specific processes. The agent has to understand your rules, your workflows, and your constraints. That's where governance and identity become the priority again. You aren't just running software. You're embedding agents into systems where they make recommendations and decisions that affect real-world operations. They have to be auditable. They have to be scoped. And they need clear ownership. This is the moment where agents stop being an optional upgrade. This is where they become the way work gets done. Integration, how agents connect to everything. An agent sitting by itself is useless. It doesn't matter how smart it is or how well it was built. If it can't get to the data and the systems it needs to do the work, it's just a language model having a conversation. That's the integration problem. Every organization has data scattered everywhere. SharePoint, Teams, Outlook, OneDrive, data warehouses, databases. Every single one of those has different APIs, different security requirements, and different ways to access the data. An agent needs to connect to all of it without being custom built for every single system. Toolboxes solve this by creating a discovery mechanism. Think of a toolbox as a managed library of tools, integrations, and data sources. It's all cataloged and ready to go. When an agent has a task, it checks the toolbox to see what's available. It picks the right tool and uses it. When you add a new tool to the toolbox, every agent gets access to it immediately. You don't have to redeploy the agent. You don't have to change the configuration. The new capability is just there on day one. Microsoft Graph is the main bridge for your Microsoft 365 data. Through Graph, an agent can see Teams conversations, read and send emails, check calendars, and pull documents from SharePoint. Graph provides a single, consistent interface for all of it. Instead of needing one connector for Teams and another for email, the agent just talks to Graph. The complexity is handled underneath. Azure AI Search is what powers the knowledge-heavy scenarios. If an agent needs to find information across a massive data set, it doesn't try to read everything at once. That would overwhelm the model. Instead, Azure AI Search handles the indexing and the retrieval. The agent asks a question. Search finds the relevant parts. The agent uses those parts to think. The agent doesn't need to know how the search works. It just needs the results. Fabric data agents work a bit differently. They aren't just for finding files. They're analytical. If an agent needs to query a data warehouse or understand a complex data set, the Fabric agents handle that heavy lifting. They understand the data schemas. They write the queries. They return the results in a way the agent can actually use. For everything else, there are MCP servers. The Model Context Protocol creates a common language for agents to talk to external tools. It doesn't matter if you're connecting to Slack or a custom internal system. If it has an MCP server, the agent can use it. This is a big deal because it means you can build an integration once and let agents on different platforms use it. Custom connectors are for the systems that don't fit the standard patterns. Maybe you have a legacy system from 10 years ago that doesn't have an MCP server. You build a custom connector that translates between that system and what the agent understands. Now, every agent can use that legacy system. You aren't writing custom code for every agent. You're building a connector that the agents can discover and use on their own. The governance layer sits on top of all of this. Your data policies don't stop at the agent. They flow through the integrations. If a document is marked as confidential, the agent sees that metadata and knows it's restricted. If you've set sensitivity labels in SharePoint, the agents respect them. They won't expose information they aren't supposed to see. The security you've already built doesn't get bypassed. It becomes part of how the agent functions. This is why integration isn't just a feature. It's the point where agents stop being assistants and start being useful. Without integration, an agent can only talk. With integration, an agent can act. The knowledge problem. Grounding agents in reality. Imagine what happens when an agent doesn't have real information to work with. Someone asks a question. The agent generates a response that sounds reasonable. The words flow, the grammar is correct, the tone is confident, and the answer is completely made up. This is hallucination. The agent isn't being deceptive. It's not intentionally lying. It's just doing what language models do when they don't have actual data. They generate plausible-sounding text based on patterns they learned during training. The result feels authoritative, and it's often wrong. In a security context, that's dangerous. In a business context, it's expensive. A sales agent tells a customer you have inventory you don't actually have. A finance agent makes assumptions about reconciliation rules that turn out to be incorrect. A support agent confidently explains a feature that actually works differently. These aren't minor issues. They erode trust. They create rework. They undermine the entire value proposition of using agents. The solution is grounding, retrieval augmented generation, RAG, is the pattern that makes this work. Instead of letting an agent generate responses from memory, the agent first retrieves actual relevant documents or data. Then it answers based on what it actually found. The response is grounded in reality, not in pattern matching. Foundry IQ is the managed implementation of RAG across your entire organization. It's a unified knowledge plane. Documents, data from your warehouse, web content, enterprise sources, all indexed and available for retrieval. When an agent needs information, it doesn't ask you to point it to the right place. It searches across everything. It finds what's relevant. It uses that to answer. The difference between old RAG approaches and Foundry IQ is operational. Building RAG 5 years ago meant custom pipelines. You'd set up document ingestion, you'd configure indexing, you'd build retrieval logic, you'd monitor embeddings. It was infrastructure. Now, it's a platform feature. Upload your documents. Foundry IQ handles the rest. Multiple agents use the same knowledge base. Updates flow through automatically. Semantic search is what makes retrieval work accurately. You don't ask an agent to match keywords. That fails constantly. Someone asks, what's our return policy? And a keyword search returns documents about policy documents because the word policy matched. Semantic search understands meaning. It knows that the question is asking about refunds and returns. It retrieves the right policy document even if that document uses different words. The agent gets relevant information, not just keyword matches. Procedural memory layers on top of this. The agent retrieves information once. It learns from that retrieval. The next time it faces a similar question, it doesn't need to retrieve again. It remembers the approach it used before. This reduces both hallucination and token consumption. Less retrieval, less uncertainty. But retrieval without governance creates a different problem. What if an agent retrieves data it shouldn't have access to? What if it bypasses your data classification? This is where the governance layer becomes operational, not just theoretical. Sensitivity labels flow through retrieval. If a document is marked confidential and your agent doesn't have access to confidential material, that document won't be retrieved. Access controls don't just prevent direct access, they prevent incidental exposure through agent retrieval. The data governance you've already built doesn't get circumvented. Grounding is the difference between interesting agents and trustworthy agents. Interesting is when the agent sounds smart. Trustworthy is when the agent is actually right. That matters enormously when agents start making decisions that affect your business. When agents recommend actions that depend on accurate information. When audit trails depend on agents knowing what they're talking about. This is why knowledge integration isn't an optional enhancement. It's foundational. Agents without grounding are worse than no agents at all. They're confident errors. With grounding, agents become reliable. Cost and efficiency, the real ROI. Organizations always ask the same question before committing to agents. We can build these, but should we? What's actually the financial case? The answer starts with efficiency. Foundry's orchestration layer cuts token consumption by about 50% compared to naive approaches. That matters because tokens are your cost driver. Every request to the model, every retrieval, every response, each one consumes tokens. Reduce token consumption in half, and you've fundamentally changed the economics. How does that work? It's not magic, it's orchestration discipline. When you're building agents without a managed platform, you tend to do things inefficiently. You retrieve more data than you need because retrieval is expensive. You reprocess the same information multiple times because you're not managing state well. You make redundant model calls because you don't have clear orchestration patterns. A managed platform like Foundry bakes inefficiency patterns. State management reduces reprocessing. Caching prevents redundant calls. Orchestration ensures you're retrieving what you need, not everything you might need. The result is fewer tokens per task. Same output, half the consumption. Cost transparency is equally important. You need granular metrics that show cost per agent, per task, per tool call. Old approaches buried costs across infrastructure. You couldn't tell whether agents were actually efficient or whether they were just invisible drains on your budget. With granular metrics, you see exactly what's happening. Agent A costs 50 cents per execution. Agent B costs $2 per execution. Now you can ask why. Did Agent B retrieve more data? Did it make more tool calls? Is there a pattern worth optimizing? You can't manage what you can't measure. But the real financial impact comes from what agents replace. Look at security co-pilots. Security analysts are expensive. A mid-level analyst costs your organization something like $120,000 to $180,000 per year in full cost. The phishing triage agent reduces the time an analyst spends reviewing suspicious messages by 70 to 80%. That analyst now spends time on actual investigation instead of filtering. That's not replacing the analyst, that's deploying them where they actually add value. If you have 10 analysts doing triage work that could be reduced by 70%, you've freed up 7 analysts worth of capacity. That's roughly $1.2 million in annual cost. That's still there. The analysts still work, but you've deployed them to work that's actually valuable. The same math applies to sales. Sales development reps spend roughly a quarter of their time assessing leads that aren't actually qualified. The sales qualification agent handles that assessment. 75% improvement in rep productivity on lead evaluation means more qualified leads getting to account executives faster. More deals in the pipeline. Same headcount. Better output. Account reconciliation in finance looks similar. Finance staff spend somewhere between 10 and 15 hours per week on manual record matching. The account reconciliation agent handles that matching. You're not eliminating the role, but you're eliminating the lowest value part of it. The person who was matching records all day now audits exceptions and validates results. They work smarter. Same cost, better use of their time. Error reduction has its own cost profile. Manual processes fail. Someone matches the wrong invoice to the wrong payment. Someone assesses a lead incorrectly. Someone misses a security alert because they've reviewed too many. Those failures create downstream costs. Rework. Missed opportunities, security incidents. An agent that makes fewer errors reduces those downstream costs. Not zero errors, nothing's perfect, but better accuracy than humans under time pressure. The scaling piece is crucial. As volume grows, agents scale with it. You don't need to hire, you don't need more headcount. You need more API calls. That's a fundamentally different cost structure. Your first analyst cost you $150,000. Your second analyst costs another $150,000. But once you have agents handling baseline work, your first and second analyst both cost less because they're focusing on work that only humans should do. Volume scales without headcount scaling. The model shifts from cost per person to cost per task. That changes everything financially. An analyst can only process so many leads per day. An agent processes them instantly. That leverage is where the ROI lives. This is how you justify agents to CFOs. Not AI is cool, but this agent saves us this much per month, and here's how we measured it. Getting started, the practical path. You don't need a 6-month planning cycle to start. You need one working agent and the discipline to avoid trying to solve everything at once. Stage 1 is about picking scope. Don't say, let's use agents everywhere. Pick one domain, one process, one clear problem where an agent adds measurable value. Maybe it's security triage, or sales qualification, or account reconciliation. Pick the spot where people are spending time on work that's mechanical but still requires judgment. That's where agents create immediate impact. Copilot Studio is your entry point because it's low code. You don't need developers, you don't need infrastructure expertise, and you definitely don't need months of planning. You open it, you describe what you want the agent to do, you give it data, you deploy it. That's the foundation. From the first idea to a working agent, you're looking at weeks, not months, grounded specifically in your organization's data. This is non-negotiable. A generic agent is worthless because it hallucinates. Users stop trusting it, and it becomes a curiosity instead of a tool. But when you upload your company's documents and connect your SharePoint libraries, something changes. The agent understands your business. It answers questions about your specific processes and your specific rules. It's not generic anymore. It's useful. Don't launch to everyone. That's the mistake organizations make. They build something in Copilot Studio. It works in testing, so they enable it for the whole company. Now it's in production. Now it's breaking. Now it's creating problems instead of solving them. Instead, run it with a small pilot team first. 10 people, a sales team, a support group. Let them use it, get feedback, learn where it breaks, understand what people actually need versus what you built. Iterate. Once you've done 3 rounds of feedback and improvements, then you start expanding. Stage 2 is making it governable. Register that agent in Agent 365. Assign clear ownership, someone responsible for that agent's behavior and maintenance. Set access policies. This isn't bureaucracy. It's the difference between managing the agent and losing control of it. Once it's registered, you can revoke access if something breaks. You can audit what it's doing, and you know exactly what data it touches. This is the invisible work that prevents problems downstream. Stage 3 is knowing when to graduate it, if the pilot is working, if users are actually using it, and if it's reducing work in measurable ways. That's when you move it to Foundry. Not because Copilot Studio is bad, it's a perfectly good place to build. But Foundry is where you build at scale, Copilot Studio is where you prototype, Foundry is where you operate. The move gets you orchestration, memory across sessions, and multi-agent capabilities. It's the infrastructure layer that lets a single agent scale to thousands of users without degrading. Stage 4 is velocity. Now you have one agent in production. You understand the patterns. You've built the governance. You've connected the data. The second agent is radically faster. You reuse the tool integrations. You reuse knowledge bases. And you reuse governance templates. What took weeks the first time takes days the second time. By agent number 5, you have repeatable patterns. You have infrastructure. You're not starting from scratch each time. The timeline is the part that surprises people. Not months, weeks. That's genuinely what managed platforms enable. You're not building infrastructure, you're not configuring databases, and you're not managing containers. You're defining logic and letting the platform handle the operational complexity. None of this requires a perfect plan. No organization has that. You need a working agent, you need the ability to measure if it's working, and you need the discipline to improve it before scaling it. That's it. Start there. Common failures, what not to do. Most agent deployments fail in predictable ways, not because the technology doesn't work, but because organizations build without thinking about what agents actually require. Failure 1 is building without any governance at all. You spin up Copilot Studio, you build something, it works, you deploy it to your department. Now it's reading from your entire SharePoint tenant because you granted broad permissions and never revisited it. It's calling APIs with credentials stored in configuration files. It's accessing data it shouldn't touch. And nobody knows it exists except the 3 people who use it. When IT finally discovers it 6 months later, it's running production workloads with zero oversight. Shutting it down breaks things. Keeping it running violates security policy. You're stuck. The agent became a liability instead of an asset because governance was never part of the conversation. Failure 2 is different, but equally costly. You build an agent without grounding it in actual data. The agent sounds intelligent, it answers questions fluently, and it's making things up. When a customer asks about product features, it invents specifications that don't exist. When finance asks about reconciliation rules, it hallucinates policies. Users stop trusting it. It becomes useless. The agent had potential. You killed it by skipping the most critical step, connecting it to real information. Treating agents as features instead of systems is failure 3. You build an agent, it works for a few months, then something breaks. Nobody remembers who built it, nobody knows who owns it, and nobody maintains it. The data it was trained on is stale. The integrations it relied on changed and nobody updated them. The agent becomes a ghost, running but not useful. Too expensive to maintain, but too embedded to shut down. This happens because nobody assigned clear ownership. Nobody planned for lifecycle management. It was treated as a feature you build once and then forget. But agents need care. Failure 4 is overscoping. You decide the first agent should solve everything. It should handle sales qualification and lead follow-up and opportunity scoring and deal analysis. It becomes unwieldy. It's trying to be good at too many things. It's actually good at none of them. The agent fails because you gave it an impossible scope. Pick one job, do that job well, add other jobs later. Not measuring impact is failure 5. You can't justify the investment. You don't know if users are actually using it. You don't know if it's saving time or just shifting work around. You can't answer whether this agent is worth the infrastructure cost. You should have defined what success looks like before deployment. How many lead assessments per day? How much time saved per finance reconciliation? Without that baseline, you're running blind. Failure 6 is ignoring orchestration. You build 3 agents. They work independently, but they need to work together. You don't have orchestration patterns. So you're calling them sequentially through manual scripts. Each agent does its job. Nobody's coordinating them. The value multiplies when agents work together. If you skip orchestration, you stay stuck at single agent utility. You miss the compounding returns. Failure 7 is not planning for scale. An agent works brilliantly when 10 people use it. You're confident. You enable it for everyone. Now it's running on 10,000 users. Token costs explode. Response time degrades. The infrastructure that worked for pilots breaks. You didn't think about scale from the start. You didn't measure token consumption early, and you didn't design for concurrency. Now you're in crisis mode, trying to optimize something that was never designed to scale. The pattern across all of these is identical. Most failures come from treating agents as simple tools instead of systems that need governance, maintenance, architecture, and oversight. You wouldn't deploy infrastructure without planning for scale. You wouldn't access data without identity and audit. You wouldn't skip integration planning. But with agents, organizations do all those things because agents feel like software features, not infrastructure. They're not. The sooner you stop treating them that way, the sooner your deployments stop failing. The organizational shift from assistance to automation. Everything we've talked about, the layers, the governance, the orchestration, this is all infrastructure. But infrastructure only matters because of what it enables. And what it enables is fundamentally different from how organizations work today. Right now, the model is assistance. AI helps humans. A human sees the results. A human makes the decision. And a human executes the action. The human is still the primary actor. The agent is secondary. It's just a tool that makes that human faster or more informed. The new model inverts that. The agent executes. The human oversees. The human intervenes only when needed. The agent becomes the primary actor. The human becomes the supervisor. That shift seems subtle when you describe it. In practice, it rewires everything. Think about a sales team. Today, a sales development rep spends their day assessing leads to see who is qualified, who has the budget, and who fits the target. It's work that requires judgment, but happens repetitively. The sales qualification agent does this assessment now. The rep reviews the results. The rep focuses on the leads the agent flagged as high probability. They spend their time on relationships and closing instead of filtering through data. That's not the same job with better tools. That's a different job. The skills matter differently now. The person who was good at quickly assessing leads might not be as good at relationship building. The person who was average at assessment but excellent at building trust gets to spend their time where they're actually strong. Job descriptions change. Hiring requirements change. How you measure performance changes. Everything flows from that one shift in what the agent does. Finance teams look similar. Controllers right now spend their time on reconciliation. 3 transactions don't match. Find why. Fix it. Manually. It's detailed work that requires attention but doesn't require strategic thinking. The account reconciliation agent does the matching. The controller reviews exceptions and validates. But the bulk of their day shifts from reconciliation to analysis, to variance investigation, to strategy. That's higher value work. It's work that only a human should do. And now a human can do it because an agent is handling the baseline. Security teams face the same inversion. Analysts right now spend their time triaging alerts. Is this a real threat? Is this noise? What matters? The alert triage agents do this assessment. The analyst reviews what the agent flagged as critical. The analyst investigates. The analyst makes decisions about response. The analyst's time moves from filtering to investigation, from assessment to action. That's the job security actually wants to hire for anyway. Now they can. IT operations shifts too. Engineers handle routine troubleshooting. Why is this service slow? Restart it. Why is this disk full? Clear the cache. These are operational tasks that someone needs to do but don't require engineering judgment. Agents do these now. Engineers focus on architecture, on optimization, on designing systems that need less firefighting. They become architects instead of on-call responders. The pattern is consistent across every domain. Work becomes more strategic, less routine, more human judgment required, less data entry, less filtering, less mechanical repetition. The things that made people tired and bored, those go to agents. The things that require intuition, judgment, relationship, and strategy, Those stay with humans. And that's where the ROI actually lives. It's not in replacing people. It's not in doing more with fewer people. It's in deploying people to work that only they can do. The analyst you're paying $150,000 a year is worth that investment when they're investigating threats. They're not worth that investment triaging alerts. Agents doing triage and analysts investigating, that's the leverage. This is why understanding the 4 layers matters organizationally, not just technically. Because the people implications flow directly from how agents are built and governed. An agent with clear ownership and audit trails is one teams can trust. An agent that's orchestrated well complements human work instead of creating new problems. An agent that's properly scoped does one job well instead of trying to do everything and failing at all of it. The shift from assistance to automation isn't about technology. It's about organizational design. It's about what humans do when machines handle the baseline. That's the actual outcome. What's coming? The 2026-2027 roadmap. The platform right now is still in consolidation mode. Things work, but they don't fit together smoothly yet. By the end of 2026, that changes. Hosted agents are approaching full general availability. They're in preview now, but the investment in data centers and orchestration infrastructure is already committed. More regions are coming online. Performance is improving. What started as a feature preview is becoming a standard way to deploy agents at scale. If you've been waiting for hosting to be stable and fully supported, that window is closing. By late 2026, you shouldn't think twice about hosting agents in Foundry. It's the default. Memory is getting smarter. Right now, procedural memory exists, but it's basic. The agent learns that when it encounters problem X, approach Y works. Useful, but limited. Over the next year, procedural memory gets more sophisticated. Cross-session learning is coming. When an agent solves something on day 1, it remembers that approach on day 30. Context retention improves. An agent doesn't start from scratch each conversation. It carries relevant context forward. This matters because it reduces hallucination and token consumption simultaneously. An agent that remembers what it learned doesn't need to retrieve the same information again. Orchestration patterns are moving from preview to general availability. Multi-agent workflows, the stateful coordination layer, is in preview. That's moving to GA. Group chat patterns, sequential orchestration with parallel branches, handoff patterns where context flows cleanly between agents. These aren't experimental anymore, they're supported paths. That means more organizations can adopt complex workflows without worrying about building on unstable foundations. Integration is expanding aggressively. More connectors, more MCP servers registered in the ecosystem, but more importantly, easier integration for organizations building their own. The friction of connecting agents to custom systems is dropping. By next year, integrating with your proprietary back-office system should be straightforward. That removes one of the barriers to scaling agents across your entire technology stack. Right now, agents access what's easy to access. Soon, they access what matters to your business regardless of how old the system is. Governance is hardening. Agent 365 started with discovery and identity. Over the next year, more policy options arrive, more granular control, better visibility into what agents are accessing and why. This matters because it's what lets organizations deploy agents more aggressively. The governance isn't a constraint anymore, it's an enabler. Teams can move faster because they have confidence that agents are operating within appropriate bounds. Cost optimization gets better tooling. Right now, you measure agent costs after the fact. Next year, you'll have models that predict costs before execution. Cost-aware routing that picks cheaper models when quality allows. Better tools for understanding where token consumption is happening. For most organizations, this is the difference between running 1 agent and running 20. When you can see costs and optimize them in real time, the business case changes dramatically. Windows Agent Runtime is coming out of preview. Agents running natively on Windows. Local execution for workloads that need to stay on-premise. For regulated industries, this is transformative. You don't need cloud infrastructure. You don't need to move data around. Agents run locally with full access to your systems. Cross-platform agents are the next step. The same agent code running on Windows, Azure, and on-premises. True portability. Write once, deploy anywhere. That's not quite here yet, but the architecture is being built. By 2027, it's realistic. The pattern across all of this is consistency. The platform isn't getting more complex, it's getting more coherent, more patterns, more frameworks, more tools. But all of it building on the same foundation: identity, runtime, governance, and orchestration. By the end of 2026, the ecosystem looks dramatically different from today, not because it's fundamentally new, but because it finally works as an integrated system instead of a collection of separate components. The structural reality, why this matters. Everything we've walked through over the last hour comes down to one thing: understanding the model, not the products, not which agent you pick for which task, the model. Because there's a shift happening that doesn't make headlines the way new features do. It's quieter, more structural, and it determines whether your agent investments actually work. The shift is from AI as a feature to AI as infrastructure. Features are things you add to existing products. You add Copilot to your Office apps. It's useful, but it's still Word. Word is the system. And Copilot is just the feature bolted on. Infrastructure is different. Infrastructure is what systems are built on. It's the foundation. It's what everything else rests on and operates through. Agents are transitioning from the first to the second, and that changes what organizations actually need to do. When agents were features, you didn't need to think about layers. You didn't need governance. You didn't need to worry about identity or orchestration. You turned on Copilot. It worked, and you were done. But the moment agents start operating in your systems, they stop being features. They call your APIs. They access your data. They make decisions that affect your business. They become infrastructure, and infrastructure requires thinking about foundations. That's what the 4 layers actually represent. The experience layer is where humans interact. That's the interface. That's the front door. Most organizations start here because they see a Teams bot or a Scout agent and think that's the whole picture. But it's not. It's the symptom, not the system. The agent layer is where domain expertise operates. This is where you define what an agent actually does. Security agent, sales agent, finance agent, each one specializes because specialization means accuracy. But this layer by itself is just logic. It can't execute anything without what comes next. The runtime layer is where execution actually happens. Your logic needs somewhere to run, somewhere to maintain state, somewhere to call tools and coordinate with other agents, somewhere to scale. That's the runtime. It's the infrastructure the experience layer depends on, and the agent layer operates within. The governance layer is what keeps everything safe and visible. Identity, policy, audit, lifecycle, these aren't optional add-ons once you're operating at scale. They're foundational. An agent without identity is invisible. An agent without policy is uncontrolled. An agent without audit is unmeasurable. These are the constraints that transform agents from experimental features into systems organizations can trust. Here's what actually matters. Each layer has different concerns. Each layer requires different thinking. Confusing them is where most deployments break. Organizations that succeed understand this. They know that an agent is the experience plus the logic plus the infrastructure plus the governance. All 4, not 1, not 2, all 4 working together. Identity is the foundation because you can't govern what you can't identify. Intra-agent ID makes agents first-class principles. That sounds technical. What it actually means is agents become manageable. You know what they are. You can control what they do. You can audit what they did. Orchestration is the multiplier because a single agent is useful. But multiple agents coordinating are transformative. But coordination only works if you have infrastructure designed for it. That's the runtime layer. Foundry isn't just a place to host agents. It's where orchestration becomes possible. Understanding this model isn't optional. It's what separates organizations building agent infrastructure from organizations experimenting with agent features. One scales, the other doesn't. The real question isn't which agent you should use. It's what your agent architecture looks like. You're not choosing between products. You're choosing how AI operates in your organization. Start with one agent. Ground it in your data. Register it in governance. Measure what it does. Then scale. The teams that understand the 4 layers move faster and make better decisions. Everything else is just picking the right tool for the layer you're building.